Good day, everyone. So our lesson for today is the four-step rule, or we call it the increment method. Other books call it the increment method. What is this four-step rule? So this is a four-step procedure in finding the derivative of a given function, or we call it four steps in finding the limit of the difference quotient. The first step procedure in finding the limit of the difference quotient of a given function. So we have here the first step, find the function x plus h, and the next is find the difference of f of x plus h and the given f of x. And then third, form and then simplify the difference quotient as f of x plus h minus f of x all over h. And then the last step is take the limit of the difference quotient as h approaches 0, or the notation, the limit of f of x plus h minus f of x all over h as h approaches 0. If this limit exists, then it is the value of the derivative at x. In short, we write it as f prime of x. Okay, first example. So find the derivative of the function f of x equals 1 using the four-step rule. Okay, so here's the solution. If f of x is equal to 1, then we write f of x plus h is equal to 1 plus h. And then we have the f of x plus h minus f of x is equal to 1 plus h minus 1. So as we subtract the given function of x, we also subtract the value of the given on the right side of the equation. And on the right, since we have 1 plus h minus 1, so 1 minus 1 here is 0. So what is left is h. Hence, the limit of the function x plus h minus f of x all over h as h approaches 0 is h over h, the limit of h over h as h approaches 0. Since a variable divided by the same variable is equal to 1, then we find the limit of 1 as h approaches 0. So learning the previous lesson, limit of a constant is always the constant itself. Second example, find the derivative of the function f of x equals x. So still using the four-step rule. Solution. So if f of x is equal to x, then we have f of x plus h is equal to x plus h. So on the right side, let's focus our solution or our eyes on the right side of the equation. So we have here x plus h, and then we will subtract the value of the given, which is minus x. Okay, so we have here x plus h minus x. Since we have x minus x, then that is 0. So what is left is h. Again, we will divide both sides by h. So on the right side, the variable h divided by itself is 1. The final expression, we will find the limit of 1 as h approaches 0. So the limit of a constant is always a constant. Therefore, our final answer is 1. And 1 here is already the derivative of f of x, or the derivative of the given function of x. We have the third one. Let f be a function defined by f of x equals x squared minus 2. So we will find the derivative f prime of x. Okay, the solution. If f of x is equal to x squared minus 2, we write f of x plus h is equal to, since the value of the given is squared, the variable x, it is squared. So even if we add h, we will also raise these terms to the second power. So we express it as the quantity x plus h is square minus 2. So we will simplify first the square of this binomial. So we write it as x squared plus 2hx plus h squared. And then we will bring down minus 2. And then we will subtract the value of the given, which is x squared minus 2. Writing the expression inside a parenthesis. Since if we write a minus sign before a group of terms, we always write first inside a parenthesis to minimize our mistakes. So we write inside the parenthesis and then we will distribute the minus sign to each term inside the parenthesis. Here is it. So this becomes minus x squared, and then negative times negative 2 is positive. That's why you write plus 2. Okay, so as a whole, the expression on the right side of the equation is x squared plus 2hx plus h squared minus 2 minus x squared plus 2. The terms to be added that will give us 0 are color-coded. So we have here shaded as blue, x squared minus x squared. So that is 0 or it is cancelled out. And then also with the constant term, negative 2 plus 2, shaded as yellow for you to see immediately. Okay? So next, what is left now on the right side of the equation is 2hx plus h squared. So the next step is we will divide both sides by h and we will find its limits. So we have now dividing now 2hx plus h squared over h. If we will divide each term by h, what is left on the first term is 2x and h squared over h is h. So we have the terms or the expression on the right side is 2x plus h. And then we will find for its limit. So the limit of 2x plus h as h approaches 0 is 2x. Why? We just give the value of h as 0 since we have here as h approaches 0. That's why what is left is 2x, and 2x here is already the value of the derivative. Okay, we have the fourth example. Find the derivative of the function f of x is equal to x cubed. We have now the solution. So if f of x is equal to x cubed, then f of x plus h is equal to the quantity x plus h raised to the third power. Okay? If we expand this binomial that is raised to the third power, we have here x cubed plus 3x squared h plus 3x h squared plus h cubed. And then subtracting the value of the given, which is minus x cubed. So we subtract x cubed as the value of the given function. On this part, if you recall the binomial expansion, so writing the numerical coefficients of the binomials, so we have when the binomial is raised to 0, the value is 1, and when the binomial is raised to the second power, so we have the value of the numerical coefficients are 1, 2, 1. And when the binomial is raised to the third power, the value of the numerical coefficients are 1, 3, 3, 1. That's why we have here x cubed plus 3x squared h plus 3x h squared plus h cubed. Observe that the numerical coefficients are 1, 3, 3, 1. Okay? So, next, since we canceled the terms x cubed minus x cubed, what is left is 3x squared h plus 3x squared plus h cubed. To divide easier, factor out h on the numerator. So we have h times the quantity 3x squared plus 3xh plus h squared. So dividing both sides now by h. Ayan. So as you observe, we canceled the variable h to both numerator and denominator. So what is left is 3x squared plus 3xh plus h squared. And we have to find the limit. So to find the limit of this expression or of this function, as h approaches 0, sa lahat ng may h ay 0 ang value. So yung 3xh plus h squared, 0 na yan. So we have now 3x squared. 3x squared now here is the value of the derivative. Okay, so I want to introduce you this method. Anyway, this is just the same, so I just want to share it with you. Maybe you can understand more easily using this increment method. So whichever you want to use later, if I will ask you to show solutions on finding the derivative using the four-step rule or the increment method, both are accepted. So, kung saan yung mas naintindihan ninyo, yun ang gamitin ninyo. So, given a function y equals x, first step is using the given function, replace y with y plus delta y and replace x with x delta x. We have here an example for you. So y plus delta y is equal to x plus delta x. Maybe this is clearer than the previous one. So second step, subtract the value of the original equation and simplify if needed. We will now subtract the given. So y plus delta y minus y, and then on the right side we write x plus delta x minus x. So if we will simplify now, we will remove x minus x since the value becomes 0. So what is left now on the left side is delta y and on the right side is delta x. And the third step is divide both sides of the equation by delta x. So we have on the left side of the equation is delta y over delta x equals, on the right side we have delta x over delta x. The meaning of delta y over delta x on the left side of the equation is the derivative of y with respect to x. So we will use dy over dx. So this means the derivative of y with respect to x. We read it as that. Or simply you just write y prime, meaning it is already the derivative of the function y. Okay? Or f prime of x is also accepted. So dividing delta x by itself, it is 1. Fourth step, find the limit of both sides of the equation as delta x approaches 0. Since the value of delta x over delta x is 1 and the limit of 1 as delta x approaches 0 is 1. So always remember the limit of a constant is always a constant. Now the fifth example using the increment method. So find the derivative of the function f of x is equal to 2x plus 1. Or simply y equals to x plus 1. So which notation do you prefer to use? You use. If you want f of x plus 2x plus 1, you just use it. Or simply y equals 2x plus 1, so that you will write your final answer as y prime. Okay, let's have the solution. So if y is equal to 2x plus 1, first step is replace y by y plus delta y and replace x by x plus delta x. So as you can see, we have on the left side y plus delta y. On the right side, we write 2 times the quantity x plus delta x plus 1. So before we will subtract now the value of the given, we will distribute first. Distribute 2 inside the parentheses. So we have 2x plus 2 delta x, bringing down 1 plus 1. And then we will subtract the value of the given minus the quantity 2x plus 1. As you can see on the left side of the equation, we also subtracted y. That's why on the right side, you subtract also the value of y, which is 2x plus 1. But if there are more than 2 terms, you place always in a parenthesis. Okay, you do it step by step to avoid mistakes. The minus sign, for the next step, distribute first the minus sign inside the parenthesis. So we will have minus 2x minus 1. So we just added to 2x plus 2 delta x plus 1 minus 2x minus 1. Okay, so before we will proceed, as you can see, there are terms that are cancelled out. Okay, so we have here 2x minus 2x, that is 0. Positive 1 minus 1, that is also another 0. So what is left on the right side is 2 delta x. And then the next step is we will divide both sides of the equation by delta x. So on the right, 2 delta x divided by delta x is 2. And then finding the limits, the limit of 2 as delta x approaches 0 is 2. That's why we have here the derivative of y with respect to x is equal to 2 or is equal to y prime. So they mean the same thing. Y prime meaning the derivative of the given function y is equal to 2. Okay? Next, we have here the sixth example using the increment method. So find the derivative of the function f of x is equal to x squared plus 2x minus 3. Or y equals x squared plus 2x minus 3. Okay, so we have now the solution. Y is equal to x squared plus 2x minus 3. Okay, replacing the variables y and x by delta y and delta x. So we have here y plus delta y on the right side, x plus delta x raised to the second power. Why it is raised to the second power? Since the first term of the given function is x squared. The first term of the given is x squared. So adding delta x to x, also we will raise to the second power. Plus 2 times x plus delta x minus 3. So before we will subtract the value of the given, we will expand first the binomial. Okay, so we have x squared plus 2x delta x plus the quantity delta x squared plus 2x. Ito, 2 times x is 2x and 2 times delta x is 2 delta x minus 3. And then subtracting now the value of the given function, which is x squared plus 2x minus 3. So as you can see, I place it first inside the parentheses because when we write minus or when we subtract terms, the signs of the terms changes. Ayan. So we will distribute the minus sign inside the parentheses. So we have now negative x squared minus 2x plus 3. Okay, so as you can see, anyway, it is shaded and coded. Both yellow terms, shaded yellow terms have its additive inverse. Kaya 0 yan. So both blue, 0 din yan. And then pink, we have also 0, negative 3 plus 3. So what is left is 2x delta x plus the quantity delta x squared plus 2 delta x. And then the next step is we will divide both sides by delta x. Okay, so delta y over delta x on the left side, and on the right side we have 2x delta x over delta x. So what is left is 2x, and the other one, delta x squared over delta x equals delta x. And then 2 delta x by delta x, we have 2. So what is left on the right side is 2x plus delta x plus 2. Okay, and then last step, we will find for the limit of the expression on the right side of the equation. So the limit of 2x plus delta x plus 2 as delta x approaches 0. So yung isang term natin na delta x, 0 na yan. So what is left is 2x plus 2. So the value of the derivative is 2x plus 2. Okay, last example, last but not the least, find the derivative of the function f of x is equal to 3x squared. So there is a numerical coefficient, and at the same time, there is an exponent. There is a power. Okay, we have the solution. If y is equal to 3x squared, then y plus delta y is equal to 3 times the quantity x plus delta x raised to the second power. Expanding the binomial on the right side of the equation, so we just write 3 first outside the braces. So the expanded form of the binomial is written inside the braces. So we have x squared plus 2x delta x plus delta x squared. And then we immediately subtract the value of the given, which is minus 3x squared. Okay, on the next step is 3x squared minus 3x squared. So as you can see, shaded in yellow. So we cancel it out. So what is left is 6x delta x plus 3 delta x squared. Dividing both sides by delta x, on the right side, we factored out delta x on the numerator first. So the other factor is 6x plus 3 delta x. So as you can see, we cancelled out the delta x on the numerator and in the denominator. So what is left is 6x plus 3 delta x. Finding the limits, the limit of 6x plus 3 delta x as delta x approaches 0. So, since 3 delta x, may delta x siya, the value is already equal to 0. Immediately cancel it out. So, what is left is 6x. Okay, so 6x here is now the value of the derivative. That's why we write y prime or f prime of x to mean the derivative of the function, 6x. The meaning of delta y over delta x is the derivative of y with respect to x. Okay, so that's all. Thank you for watching, and I hope you are starting to enjoy our learnings in calculus. Bye.